In this video, you're going to discover more about strong and weak acids and what makes them this way. The word acid comes from the Latin word acer, meaning sour, and you may have eaten some of them today. Lemons contain citric acid and makes the flavor of others seem less acidic. Tea contains tannic acid, vinegar ethanoic or acetic acid, and fizzy drinks carbonic acid. In contrast, strong acids are often used in school science labs for experimentation, but they have important uses in industry and the everyday world. Sulfuric acid, for example, is found in car batteries, but industry uses 200 million tons annually for the chemical industry. Hydrochloric acid, found in your stomach, and nitric acid are also examples of strong acids. We have established in our video what makes something acidic, that acids react with water to produce hydrogen ions, or more strictly speaking, hydroxonium ions. Strong acids, like the three mentioned above, dissociate 100% into their ions, like this. Most acids are weak and remain largely as molecules in solution, i.e. they do not ionize very much. Note the equilibrium arrow here. Acids can be identified by using full-range indicator from 0 to 7 on the pH scale. pH is a measure of the concentration of hydrogen ions. For example, at pH 0 there is 1 mole of hydrogen ions per liter. At pH 1, just 1/10 of a mole of hydrogen ions per liter. Each increase of 1 unit of pH is a 10-fold reduction in hydrogen ion concentration. So when you reach pH 7, there are only 10 to the power -7, or 0.0000001 mole of hydrogen ions per liter. Here there are also an equal number of hydroxyl ions, and we have arrived at pure neutral water. If you dissolve 1 mole of a strong acid like HCl in water to make 1 liter of solution, it dissociates completely into ions, so you also get 1 mole per liter of hydrogen ions and a pH of 0. To get a solution of, for example, pH 4, you need to dilute this with 10,000 times its volume of water. We still have a strong acid, but it is very dilute. However, if you dissolve 1 mole of a weak acid, like ethanoic acid, also called acetic acid, to make 1 liter of solution, it remains mostly undissociated molecules. That's why it smells. The molecules can easily move into the air. Let's say the acid is only 0.01% dissociated, so only 1 molecule in 10,000 are split into ions. Although the concentration of the acid is 1 mole per liter, the concentration of hydrogen ions is only 0.0001 moles per liter. That is 10 to the power -4, making the pH 4. So here is an example of a fairly concentrated acid which is weak. Here are 2 common weak acids, vinegar and carbonic acid. Vinegar is also known as acetic acid or ethanoic acid. Ethanoic acid reacts with water to produce hydroxonium ions and ethanoate ions. Strong acids, however, are totally dissociated into their ions, which is indicated by the non-reversible arrow in the example shown for hydrochloric acid and water. So a little test to summarize. Here are the 4 pictures that you saw earlier of some acids dissolved in water. Can you say which 2 show concentrated solutions and which 2 show dilute solutions? And can you say which 2 represent a strong acid and which 2 represent a weak acid? Pause and think. Well, here is the answer. A is both concentrated and fully dissociated, so strong. B is also concentrated but not fully dissociated, so weak. C is dilute but strong because it is fully dissociated, and D is dilute and weak. Most acids are commonly occurring organic acids such as you find in lemons or vinegar, which are all weak, so remain mostly as molecules and often have a smell. There are only a few strong acids, mostly non-metal oxides, dissolved in water like sulfuric and nitric acids. but there's also hydrochloric acid found in your stomach to aid digestion.